Okay, folks, here we go. The AP 2017, number 5. It was a non-calculator question, but we'll be able to use our calculator for it. What we're going to do is I rewrote the question out here so we have it. If you want to find it in your packet, it looks like this one right here. I'm going to move this page off so you can see my notes, and I'll read the information to you. It says two particles move along the x-axis. They're going to use that a bunch. When that happens, when things move along the x-axis, this is the positive direction. This is the negative direction. From time 0 to 8, a particle P, its displacement, its position, a particle P is given by this equation. There's another particle Q, whose velocity is given by this equation. And at t equals 0, Q is at position 5. So before we even begin the problem, we already know this is a diva problem. Displacement, the derivative of displacement is velocity. Derivative of velocity is acceleration. And the other way around, the integral of acceleration is velocity. Integral of velocity is displacement. They're not going to ask us to do a lot because we're going to have to take derivatives and not use a calculator. These things should give us very straightforward answers, as well as they may ask us to factor. But remember, factoring here is not going to be bad, I promise you. Okay, so part A says when t equals 0 to 8, when is P moving to the left? Well, when P is moving to the left, and we know the direction of things is given to us about its velocity, so we need to know when the velocity, v sub P, well, velocity of P would be the derivative of the statement above, which is 1 over, ln of something is 1 over the something, times the derivative of the inside, which is 2t minus 2. I'm going to turn that into one fraction. V sub P, the velocity of P equals 2t minus 2 over t squared minus 2t plus 10. And the way we find when velocities are positive or negative is first we find whenever the velocity could be 0. So the only way for velocity to be 0 is when the top is 0. So the top of this function is 0 when t equals 1. Because that makes 2 minus 2, 0, so put that in there. And now we need the velocity on either side of the function. So let's stick in 0, because 0 would be the easiest number to stick in. That'd be 0 minus 2 over positive 10. So negative over positive would be a negative number. And on the other side, we can put in a number. We can only go up to 8. Let's put in something easy. Let's put in 2. 4 minus 2 is 2. 2 squared is 4 minus 4 plus 10 is positive. So it's a positive number over positive. It gives us a positive answer. Okay, so when is the particle moving to the left? That's this way. That's when the velocity is negative. So it's this one right here. Normally we'd say anytime before 0, but we know this function starts at 0 and ends at 8. So this function is moving left between t equals 0 and t equals 1. And you can do it just like that. If you want to write it with brackets, you could say 0 is equal to t less than 1. Because at 1 at 0, we can't put an arrow on there. That's why I choose to write it out that way, as opposed to the other way. Okay, next part. Between 0 and 8, find all times that P and Q are moving in the same direction. So we have to check when P and Q have the same, not the same velocity, the same sign for velocity. Okay, so we now know velocity of P. I'm going to draw a little number line graph. I'm going to redraw the number line graph for P between 0 and 8. At 1 at 0, it's negative here, and it's positive here. So now I need the velocity for particle Q. So I've got it written right here, velocity of Q. So I'm going to put it here and then work it over on the thing there. So v equals t squared minus 8t plus 15. I need to find where the zeros are, so you're often going to factor, but the factoring is never going to be hard. It's t and t. Both sides are negative. Factors of 15 are 5 and 3. So these factors are t equals 5 and t equals 3. So I'm going to put this underneath here, q. Let's go 0, 3, and 5. That's 0. So now I have to check q in between all these numbers right here and see what I get, positive and negative answers. Okay, in between 0 and 3, if I put 1 in, I'm going to put 1 in, I get 1 minus 8 plus 15 is a positive number. Now let's put in something bigger than 5. Let's put in 7. Okay, 7 squared is 49. Write it down. 7 times 8. 42 plus 15. I'm going to get a positive answer here. I'm guessing I'm going to get a negative answer between 3 and 5. Let's put in 4. 4 squared is 16. 16 times 8 is 32. Plus 15. 16 and 16 is 32, so I get a negative answer in there. So the only times where the signs of these, they move in the same direction, let's see, are between 1, between 1 and 3. Yep, they're positive. Between 1 and 3, v is positive. Is there any time else where it matches up? Let's see. Oh, between 5 and 8. Between 5 and 8, v is positive. They both have the same sign. You don't have to put the positive in there, just want to know when they have the same sign, but we can go with that. That's good enough right there. Okay, they asked me to find the acceleration of q at t equals 2. Well, acceleration is the derivative of velocity. So to find acceleration, I'm going to take the derivative of v sub q of t. So I can write it in many different ways. Let me get a different color here. Let's write it as, I'm going to write more symbols than I have to. I'm going to write down a sub, that's an a. Still not an a. A sub q sub t equals v prime of q sub t. More symbols than I need. Equals, take the derivative there, is 2t minus 8. And they want me to find the acceleration at time 2. A sub q at 2 equals 2 times 2 is 4 minus 8, which equals negative 4. And they want if the object is speeding up or slowing down. Well, this gives me the acceleration at time 2. We also need the velocity at time 2, and we can tell everything we need then. Let's put 2 into velocity. That's 4. Hey, Grady, I'm on the phone. Sorry. Thank you. That's 4 minus 16 plus 15. And so v sub q of 2 is 3. So this is slowing down. And why? Because those things are fighting each other. Because v sub q is positive and a sub q is negative. That's enough to get you full credit on the answer right there. Okay, so let's take a look at the last part. We never fully worry about this one. It says find the position of the particle q at the first time it changes direction. So particle q, I think we already found, changes direction. Yep, at time t equals 3, because the velocity went from positive to negative. So it changes at 3. Changes at t equals 3. So if I want to find its position, it's going to be wherever it started at. So it started at 5 plus how far it went between time 3, 0, and time 3 of v sub q. of t dt equals 5 plus the integral from 0 to 3 of t squared minus 8t plus 15. That's the velocity of q at that time. Remember, the integral velocity of displacement. So even though we have a calculator, I'm going to work this one out just so you can see it. This is going to be 5 plus, in parentheses, 1/3 t to the third minus 8 over 2 t squared plus 15t from 0 to 3. On a non-calculator, that's enough to write on out. I'm going to work on it out for us just so I can see it. So it's equal to 5 plus, I'm going to fill in the 3, 1/3, 3 to the third minus 4, 3 squared plus 15 times 3. And the 0 I can just dump because I get 0, 0, 0. Let's fill it in. I get 5 plus, this is 9. This becomes 9 times negative 4 minus 36. 15 times 3 is 45. On a non-calculator, you can leave it like that. You can work it out and get 23 is the right answer. Or I could, in my calculator, just put this into the integral sign and got an answer on out. Okay, ladies and gentlemen, there's that. We have one more total to go. I will send that out later. But there's my ones for today. I'll review them, get them in your notes, be ready for Tuesday. On Monday when we meet, we're just going to talk calculator tools. Talk to you then. Bye.